Okay, now let's take that same example and do all NOR. All right, so we do the same process where we identify the function. So the very first function that I've highlighted in green is OR, but I want to implement this with a NOR gate. All right, so OR function with a NOR gate means I need a bubble on the output. All right, so that takes care of the first input. All right, now let's consider the second input. I need an AND function, x bar and y. All right, to get an AND function with a NOR gate, I need bubbles on the inputs. All right, so that takes care of the second term. All right, then for the third term, again, I need an OR function. If I'm going to use a NOR gate, I put a bubble on the output. And that's our third term. And then what I know we're going to do is we're going to take each of these terms, 1, 2, and 3, and we're going to AND those together. The logical function is AND. Okay, so I draw the and then I ask myself if I want to implement an AND function with a NOR gate, I would need bubbles on the inputs. Okay, now let's fix everything else up. All right, so coming in, if I want to have a bar, I would need to invert to get a bar to show up on the output, and C would not need an inversion. Okay, so for the second gate, if I want X bar, if I take X straight and hit the bubble, on the other side of the AND is X bar, and then for Y, I need to invert that first. The bubbles cancel, Y would go straight to the output, and the function is AND, so it'd be X bar and Y. All right, and then B, and I would need to invert to get D. Okay, now we need to check our bubbles. This cancels, those bubbles cancel, so we're good. All right, I need to cancel this bubble, so I have to have an inverter, and this one's already set up. All right, so there we have it. That's the all NOR implementation of the logic function.